negative 3y, correct? And then that, now I want the x's and the y's on, oh, but they're divisible. Both those numbers are divisible by what?
4.
4. So I can divide both sides by 4. 3. Yeah. By 3. So I can divide this by 3 and I can divide this by 3, correct? And I want to do that to get the smallest numbers. So I get 4x equals a negative y, correct? Now to put in standard form is a capital AX plus BY equals C, correct? So what do I got to do with this y? It's got to move it over. So if I move it over, it becomes positive. We learned that yesterday. And then what's over here? 0. You took it away. There's nothing there. And this is in standard form. And it was yes. Okay? All right, yes.
Would you change from negative y when you move it?
Yesterday I showed you that. Whenever you move to the other side, remember we subtract it? It becomes the opposite sign. I remember we spent the first 10 minutes of the class period going over that. Did you write that in your notes? Okay, all right. Now let's take a look at 19 and 20. It says find the x and y intercepts of the graph of each linear function. Okay, take a look at 19. All right. What are the x and y intercepts again? What are the x and y intercepts? Okay, so it's where it touches the x-axis and the y-axis, right? All right, let's start with the x-axis. Take a look at that graph on number 19. Where does it touch the x-axis at? Where at, Tyra? 3. And what's the y value at that point, Tyra?
4.
No. I want the y value at 3. You said it touched the x-axis at 3, and I'm asking you at that point at 3, what's the y value?
2.
No, Mr. Lords.
0.
It's 0. It cannot touch the x-axis if it wasn't 0, could it? All right, Tyra, do you understand that?
Yeah.
Good, I'm going to come back at you then. What's the y-intercept?
4.
Okay, so what's the x value at that point?
0.
There you go. You see the difference? And on all x and y intercepts, the other value is 0, isn't it? Okay, so on 20, all you got to do is look at the table and see where the zeros are, right? Correct? All right. Take a look at the next page. Now on 21 and 22, on page 148. Number 21. What's this about? Are you on the right page there, Jackson? You know, Jackson, I watch you two. And I watch you two, and you're never where we're at. It's always, okay? You need to stay with us so you can ask those questions. Okay? And then you wouldn't have the questions you have the next day. Okay? So take a look at 21. What's this about, Chuck? It's an eagle, right? Okay. And can you tell me what the x, this is number 21, can you tell me what the x value is, or the x-intercept is? Because it says find the x and y intercepts and then describe what the intercept means. What is it? 6 what? What's the y value? We just talked to Tyra about this. 0. Okay, so what does that mean? What does that mean? Take a look at, what does that mean? Ashley,
That's 6 seconds.
6 seconds for what?
It takes 6 seconds for the eagle to descend
To where?
from 20 feet.
To what? Yes, for the eagle to land, right? 6 seconds for the eagle to land, doesn't it? All right, now what's the y-intercept? Jackson, what's the y-intercept? 0, 20. Very good, Jackson. Okay, what does that mean, Jackson?
That it's 20 feet.
He came from 20 feet, right?
Yeah.
So the initial height, the first height, I'm going to use first because I don't know if you understand initial. The first height is 20 feet. Okay? Can you fall in 20 seconds? I don't know. Or not. It'd be 6 seconds that you fell 20 feet, wouldn't it? That's quick. That's pretty quick. All right. Now, if you're a rabbit, that means a lot, right? Or a small chihuahua. You want to figure out how fast you got before that eagle gets to you, right? Right? All right. So it's kind of a big deal to them. All right. Okay, you do that on 22 too. That's a table. Now, would you read 23 through 28 there? Let's talk to Tater. Would you read that?
Graph each equation by using the x and y intercept.
All right. Remember these yesterday? Remember these yesterday. I'm going to start 23. 23 says y equals 4 plus 2x, correct? All right. I use an x and y, I use a t-table, correct? Remember we called this a t-table. All right. So if I want to find the x-intercept, what's the value of y, Allie? 0. So I put 0 in for y, and I want to solve 0 equals, and I put 0 there, and 4 plus 2x. Remember doing this yesterday? And so I move the 4 over. Jackson, when I move the 4 over to the left side, it becomes what? Negative. You see how that works? And then I divide by 2. Why am I teaching you that, Jackson?
So I know what I did.
It's quicker, isn't it?
Yeah.
Yep. So I get x equals a negative 2. So my x-intercept is a negative 2, 0. How do I find the y-intercept? How do I find the y-intercept? What's that? Put 0 in for x. All right, I put 0 in for x. And I put, so I have y equals, and notice I put it in here, 2 times 0, right? And so I get y equals what? 4. So my point is 0, 4. Now, what did it say? It said graph each equation by this. So what do I do now? I do what? Graph it. Thank you. So you need a straight edge, right? Okay? You need a straight edge. So I do this. I'm going to bring this down. And I go, my x-intercept is a negative 2, 0. And my y-intercept is 0, 4. And then I think I gave you a straight edge yesterday, right? And you just graph it that way, right? Okay. Questions about that? Why am I doing this today? Okay, so you get a better grasp on it, right? Thank you, Tirsa. All right, you understand that. You do that for each one of those, right? Okay, yesterday I told you about 2 lines that were kind of pains. What were they? What's that? Vertical and horizontal. Okay. And what's the vertical? What's its formula? Remember from your notes yesterday. It was x equals some number. Okay? Take a look at 29. Take a look at 29. What does it say? X equals negative 2. What kind of line is that? It's a vertical line. Let's take a look at that. A vertical line. How do I make a vertical line at x equals a negative 2? I start here. I go 1, 2. And I make a vertical line. We got that? What else does it say in the directions? What's that? Yeah, we don't need a table on that one, do we? It says domain and range. Why don't we need a table? We know it's just a vertical line, right? It says domain and range. Domain and range, right? Okay, I'm going to teach you something here. The domain is what x values does this line have? There's only one x value that it has. -2. All the values on this line is a -2, correct? So we write it like this. A bracket and a -2. And what the bracket says is it touches a -2. That's the only number in there. Now, what's your range? How high do you go? How high does that line go? Infinite. How low does it go? Infinite. Range is up and down, right? So it goes all real numbers. This is how we write all real numbers. I'm going to show you this. What are those things? Those are infinity. What it says is it goes from a negative infinity to infinity. What are the parentheses? The parentheses say we don't touch it. Brackets say we touch it. Brackets say we touch it. Parentheses say we don't. Can you touch a negative infinity? No. Can you touch infinity? No. Okay? Jackson, you've been playing with your protractor. Do you understand this? Good. All right. All right. Take a look at 30. What is that? It's what? Y equals a -4. Y equals some number. That's a horizontal line. So you go down to a -4 and you graph it, right? So it'll look something like this, right? Okay? Now we switch around. What's your domain? No. No. That's right. Your domain goes from a negative infinity to infinity. What's your range? -4. Why the brackets? Because it can touch it. All right. Now let's take a look at number 31. Y equals a -8x. Is this a vertical or horizontal line? I'm asking you, is it one or the other? Or neither? It's neither. Tell me why it's neither. It has an X and it has a Y. All lines that have an X and a Y are what we call, the word slips me. Oblique. Thank you. Oblique. Oblique means they're slanted. Okay, now it says use a table, T-table, to graph it. So I do this. All right? What point can I use? You remember what Ashley said? She can use any point she wants. Now, if you use 0 and 0, you get intercepts, right? But what would happen is, let's take a look at this line. What's easier to plug in for, X or Y? If I put a number in for X, is it easier to put a number in for X on this one or Y? I think it would be X. Watch this, Ashley. Let's say, Ashley, pick a number.
2.
Okay, if you put 2 in, look how easy it is to put it in for X. 8 times 2. Whoops, -8 times 2. So what do we get? -16. So we have the ordered pair 2 and -16. Now, do you want to graph that? Isn't a -16 pretty big? Right. Should we pick another number for X? 1. Oh, why did you pick that, Ashley? Who picked that? 1. Oh, Jackson? Why did you pick that? That's a lot smaller, isn't it? So we got 1 and -8, right? Do I have 2 points? You know what point I would always pick for X? 0. Why? All right, look at this. I get 0, 0. Isn't that point fun to graph? Now, I can graph all three of them, right? I don't know if you can see this. I'm going to graph. I don't want to graph 2 and negative 16y. It's huge, isn't it? But I can graph 1 and negative 8. So 1, 1, 2, 3, 4, 5, 6, 7, 8. I can graph that one, and I can graph 0, 0. And then I use a straight edge, and there I have it. Now this is what we call oblique line. Why is it oblique? It's not vertical, and it's not horizontal.
Was that what we break?
Yes. Now we got. Oh no. You graph it, and then they want the domain and range. And I'm going to show you the domain and range. Guys, listen very carefully. I'm going to give you a shortcut right now. The domain and range on all oblique lines is a negative infinity to infinity. Do you understand that? If it's not vertical and it's not horizontal, it's oblique. This is the word, oblique. Oblique lines, the domain is a negative infinity to infinity, and the range is a negative infinity to infinity. So while you're trying to figure out the domain and range, just write it down. The only time it changes is when we have a vertical or horizontal line. Do you understand that? Okay. That should save you a ton of time, shouldn't it, Ashley? All right. Okay. So, yes, Katie, do you have a question? You sure? All right. Can we talk about the story problem? Would you like to talk about number 35?
Yeah.
The number of people who watched a singing competition can be given by P equals 0.15V. That's a very small number, guys. Where P represents the number of people who saw it, and V represents the number of people that could potentially see it. V represents the number of people that get that channel. P is how many people actually watch it. You understand the difference? V is the potential viewers, which I thought was always backwards, and P is the actual viewers. You understand what I'm saying? So this ordered pair should be VP. V comes first and then P, and I know they don't come first in the alphabet, but that's the way it works on this one. We've had a lot of mistakes for that. It says make a table of values for the points VP. All right, let's make a table of values. This is A. Okay? What should I put in for V? What is the first number that you think you should put in for V? 0. Whoops. This is V and this is P. Treat it as X, Y, okay? So if I put 0 in there, what do I get back for P? Yes?
So when you have like a story problem with specific variables for these, can you change them to X, Y?
No, I wouldn't in this case because they're actually defining V and P for you. Okay, that's a good question though. So if I put 0 in for V, what do I get back for P? 0. So my graph goes through 0, 0. What's another number you want to use for V? 1 would be a very small number. 1 times 0.15 is 0.15. Let's pick a bigger number. So, could I go 10? What is 10 times 0.15 without a calculator? Who can do that? 1.5. Thank you, Miss Tyra. All right. So do I have two numbers? Do I have two numbers? Can I graph it? Let's graph it. All right. Now this is kind of weird. Can you guys remember those numbers, or I can slide it up, I guess? Yeah, it's over here. Okay. All right. Now we got a label, right? So this is potential. potential viewers, right? What is this? What's the Y? The actual viewers. All right. So we want this to be 1, right? 2, 3, 4, 5, 6. We went to 10, didn't we? 7, 8, 9, and 10. Right? Okay. We good? Now, I want my Y to be different. Can I change my Y? Can I make every 5 1? Why would I do that? I don't like you to do this, but why would I do it in this case?
So making 0.5 easier.
That's right. Okay, thank you. So we know that we go through 0, 0, right? What's the other point? 10 is 1.5, right? Watch this, guys. Watch this, Tater. 1 is right here. Right? Every 5 is 1. So how do I do a half? Tater? How many squares are a half? Half. How many? If this is 1, how do I do a half? If 5 squares is 1, how do I do a half? Braxton?
2.5 squared.
2.5 squared. Do you understand that, Tater?
Yep.
All right, so now I'm going to connect those two. Right? That's a long ways. Here's my graph. Now remember, and this is in millions. Oh, I forgot to put that. This is in millions. Right? That's what it said. It was in millions. I got that from the... It's not like 1.5 people watched it. It was 1.5 million people watched it, okay?
1.5 people can't watch.
Yeah, no, that'd be tough. All right, now what does B say? We graphed the equation, right? So this is B, right? This is A, this is B. Correct? All right. Take a look at C. Will you read C to me, Chuck?
Use the graph to estimate the number of people who saw the show, but there are 14 million potential viewers.
Oh, 14 million. Uh-oh. 11, 12, 13. Oh, it's right there. So we have to keep our line going, don't we? I got to use the graph, don't I? So I got to go clear out here. And if I go 14 up, it's about right here. Oh, goodness. We're off the charts, aren't we? Now we got to estimate. Okay, so this is 1 million, right? And the next 5 is 2 million, right? Is it over 2 million?
Yep.
How far over 2 million? Just barely, right? So what are you going to put for C? How many million? We know it's over 2, less than 3. It's right here.
2.5.
I don't think it's 2.5. Remember that it takes 2 squares to be a half. What? I think it's about 2.1 million. 2.1 million what? Viewers. Do you see that, Jackson?
Yeah.
It's just barely over. Now, what does D say? What does D say? Allie?
Explain why it would not make sense for B to be a negative number.
Okay, the potential viewers right here. Why wouldn't it make sense that these weren't negative? I mean, do you notice we're in quadrant 1, everything's positive. Why wouldn't it make sense if it was negative?
So that means there's no people watching.
It wouldn't mean there were no people watching. It would be negative people watching. That doesn't make sense. You can't have negative people. I mean, you can have negative people attitude-wise, but you can't have negative people body-wise. So everything has to be positive. I'll let you figure that out. All right? Are we good? Okay, you want me to be quiet so you can work? All right. Any other questions? All right, and we'll be quiet.